So here in this lesson, we're going to introduce the concept of a slope field. So a slope field is a representation. It is a visual of a differential equation. So what it does is it shows the slope of all the particular solutions. So now remember, when we did particular solutions in a previous lesson, when we solved our differential equation, we did not leave it with plus c, right? We used a specific point to figure out what that plus c was. So like here, for example, this is the slope field of dy dx is equal to 2x. So what we're saying is, notice like right here at the point 1, 0, well, x is 1. So if I were to substitute 1 here for x, notice how I'm getting dy dx a slope of positive 2. Notice how it's a positive slope here versus notice at negative 1. So if I had negative 1, now notice the slope is negative 2, and notice the change in the direction. So here, ultimately, notice that that's why these lines are changing, because at given points, the slope is different. So like here, if I wanted to know then what was the original equation, right? So here, remember, with our respect to x, we're saying y is equal to the integral here, which is x squared plus c. So this visual is representing the general solution here of x squared plus c. What if c was 1, right? How would that graph look? What is the slope at different points? What if c was negative 1, right? So notice here, that's why there's a different line. Now, to show you a little bit more of a visual so you could see here, keep in mind, when we had the graph of x squared, that was our parabola, right? Our U-shaped graph here. So now what we'll do is I'm going to also show y'all, and it's going to be in Google Classroom. So this GeoGebra. Now, it starts off with the graph of here, but we'll go ahead and say that this is, we're going to look at the graph dy dx is equal to 2x. And look, there it is. Because remember, right, what we just said, that x squared is the parabola here. So now notice, what if I changed my point? See, notice here, if I change my point here, my c, it changes my graph, and notice the slope. It matches with the slope, almost like as if it's a current. So now if I were looking at point A, right, and point A is at, so like let's say here at 1, 2. So notice here now I'm changing my graph, going through a specific point. So again, it's just representing all of the different graphs that this could be here. So again, the general solution. So here, we'll go through and create but a smaller one. Now, notice how we've got both x and y. So like, let's say, for example, we want to check the point 1, 0. So that means if we're checking the point 1, 0, then that means x is 1 times y is 0, because we're testing the point 1, 0. Notice here, you just get a slope of 0. So that means we would just have our flat line here. I'll change the color, a flat line. So basically, that means here, 0.20 would also have a slope of 0, 0, right? All across here. That would be a slope of 0. So then notice here, we'll change our point, right? Let's say I want 0, 1. So again, 0, 1, same thing. 0 times 1, which is still 0. So again, our slope of 0 here. Now let's get into, like, let's say the point 1, 1. So again, we're just substituting. We're multiplying 1 times 1, which is 1. So now we're going to have a positive slope of 1. So I'll just go through and draw here. So this could represent my slope of 1. Now notice 1, 2, right? Let's say the point 1, 2. That means what we're doing here is 1 times 2, which means we have a slope of 2. So now notice it'll be a little bit steeper. and there's a slope of 2. So then here, 2, 1. Well, 2 times 1 is 2. So again, a little bit steeper. Then 2, 2. Well, 2 times 2 is 4. So steeper, slope of 4. So then here, 1, negative 1. Well, 1 times negative 1 is negative 1. So again, now a negative slope. And 1 times negative 2 is negative 2. So again, negative, but a little bit steeper. So here we'll keep going, right? 2 times negative 1, slope of negative 2. So again, same slope here. And then 2 times negative 2 is negative 4. So still a negative slope, but steeper slope. So here, try these. So negative 1 here and negative 2 here. Then negative 2 here and negative 4 here. So then here, now notice we're multiplying two negatives. So now you should have noticed this was a positive 1 slope here. Positive 2, positive 2, and positive 4. That is a little kind of rough here, but of our slope field. Now, this kind of really doesn't really make much sense, right? So let's go ahead and take a look then at the overall visual, right? So we'll go ahead and do X, Y, and here it is. So notice kind of, we just did the short here, but notice there's our slopes of 0. Notice as we change the point A, right? We're changing our C, and notice the graph changes as well. So again, there's all these different solutions. The slope field just shows the direction, right? The current of our graph here of what A, when it changes, what A is, what C is, and changing our slope here. So here, let's do another one. Now notice this is y minus 2 times x. So if I wanted to know the point 0, 0, well, that's just 0, right? So here, we'll do a flat line here of 0. So y, let's say the point 1, 1. So that means here we've got 1 minus 2 times 1, which is negative 1. So we've got a slope here, but of negative 1. So then let's do 1, 0. So here that means x is still 1, but now y is 0. So that's 0 minus 2, so negative 2. So a little bit steeper, but a negative. So then here, 1, 2. Let's change our y to 2. 2 minus 2 is 0. So we'll make our flat line here. So again, I'll keep going. How about let's do when here x is 0. All right. So here, when x is 0, when y is 1. Well, that's just 1 minus 0, which is 1. So a slope of positive 1. When x is 2, 2 minus 2 is 0. So then here, let's change our y value now to negative 1. Negative 1 minus 0, negative 1. So a negative slope here. Then here, negative 2. Negative 2 minus 0, negative 2. Then I just realized, sorry about that, 0, 2 is not a slope of 0. Silly me, because I did 2 minus 2, but that's 2 minus 0, which is positive 2. There we go. So steeper. So here, we'll continue this column here where x was 1. So when x is 1, so now let's do negative 1. So negative 1 minus 2 is negative 3. So steeper than negative 2 here, but still negative. Then negative 2. Negative 2 minus 2 is negative 4. So again, still a negative, but steeper slope of negative 4. So here, pause. Try the rest of these here when x is 2 and when x is negative 1. So here you go. So here, when you were at x of 2, and there we'll start at up top, right? And we can work our way down. So when x is 2 here, or sorry, when y is 2, 2 minus 4 is -2. And then I realized here, I apologize, this one here also needs to be changed. Oh no, sorry about that. No, there was another one here, but yeah, we fixed it. So then here, when y is 1, y minus 4 is -3. Then here, when y was 0, that's -4. Then here, -1. So now here, I'll write this one. -1 minus 4 is -5. So we're getting even steeper here. And then when y is -2, you get -6. So an even steeper, but still negative. So then here, when x was -1. All right. So here, starting up top, so that's 2 plus 2. So now that's a positive for slope. Then here, when y is 1, that's 1 plus 2, which is 3. So here, positive slope, but not as steep. And then when y is 0, that is a slope of 2 here. Then here, now notice, and I'll write it out, this is -1. -1 plus 2 is 1, positive. And when y is -2, we end up with 0. So again, if you want to see the overall visual of y minus 2x, because this is just a partial, right? So again here, y minus 2x. There's our graph. So again, notice here, that's kind of why we've got some areas that there's like that slope of 0 that we got. There's that slope of 0. And then again, changing our value. So notice how that value of c, right? As it changes, so does the slope. So it's again showing all of our different values here, our different possible particular solutions. Oops, sorry about that. Hold on one second. I realized, I think there was one more here I was going to try and do with you guys. There it is. Sorry, I got the problems out of order. So here, let's take a look at this one. Which of the following is represented by the slope field? So sometimes what I like doing here is notice how there's all the in-between. So this one is more. But I notice here, I'll go ahead and find particular points. So like notice at 1, 1, I've got a positive slope here. So at the point 1, 1. So let's see. If x is 1, then I get a slope of 2, right? Which is positive. Keep in mind we're checking to point 1, 1. So that's a positive slope. So when x is 1, you end up with 1, which is also a positive slope. Then here, x plus y. So again, 1 plus 1 is 2. And here, 1 divided by 1 is 1. So that kind of point here didn't help us. But again, you notice the drift here, right? So let's try another point. Let's try, let's say here, let's do -1, 1. So notice -1, 1 has a slope of 0. So that could definitely tell us what's going on here, right? So we're going to test the point -1, 1 and see what gets us a slope of 0. So here we go. When x is -1, 1 plus -1 is 0. So far, so good. When x is -1, well, you get +1. So B is not it. -1 plus 1 is 0. So far, so good. -1 divided by 1 is -1. So now we're down to A or C. So let's keep going, right? If I've got, let's say, the point -1, 3. Notice again, we've got a positive slope here. So -1, 3. Here we go. Well, 1 and x is -1. Well, what's 1 plus -1? 0, but I need a positive slope, where here, -1 plus 3 is 2. So here, and then of course we could check other points to make sure and verify that this represents x, the slope field of x plus y.